Good day. My name is Shaili Madondo, a student from the University of South Africa. I'm here to present to you my geological site investigation report as to perform a site investigation for a new proposed development. The report sets out the findings from the investigations and provides information with regards to the identifying potential hazards as well as engineering properties of the surface deposit that blanks the site. It also puts forward recommendations with regards to design and construction of the foundation due to the occurrence of the results of the field work. The nature of geotechnical engineering is such that variations in soil conditions may occur even where sites seem consistent, and with this region having to undergo rapid urban and industrial developments during recent decades, it may be underlined by dolomite. The site is located in the city of Tshwane, Gauteng province. The suburb is bordered by the R55 on the western side and M10 as follows. The site sits at a relatively low point between two hills, at an elevation of 1,380 meters above mean sea level. The site slopes from the west to the east at an average rate of 1.8%. The site will be excavated 6 meters below the ground level, which will develop the new construction. On the screen, I have shown you the site. The town Centurion which is approximately 5 kilometers from the site. The climate is warm and the temperatures range from mid-20 to mid-30s in summer. The summers have a good deal of rainfall, while the winters have very little. The location is classified as CWB by the Coben NGM. The average annual temperature in Centurion is 17.6 Celsius degrees and with a rainfall of 661 meters. The regional geology is as follows. The site lies over a Menilum formation of the Chinospot group, which contains dolomitic strata. According to the 1s to 250,000 West Rand, 2,628 geological map, the entire site is underlined by sediments Millennium Formation under the Chinospot group of the Transvaal supergroup. The site is underlined by dolomite, chat, and remnants of the chat breccia of the Riohot Formation. The dolomite-rich Millennium Formation is notorious for its sinkhole and dual-line formation that poses a considerable risk to the development of the infrastructure and human lives. These are the following methods of investigations that were used to produce this report. Firstly is the fieldwork. The fieldwork for the investigation in the laboratory is carried out as follows by the dynamic cone penetrator test. The DCP shall be done to assess the consistency and variability of material up to a depth of 2 meters. The DCP penetration test provides measures of material resistance to penetration. This includes the test pits excavation, retro-core drilling, gravity surveying. Number 2 is the laboratory testing. The following laboratory tests were carried out to produce this report: particle size distribution and grading, moisture content at a bed, and the rest that are showing on your screen. This test, we have learned about them in the previous modules and semesters. Other methods also include the prolocation tests, ball penetration test, texture depth, and nuclear gauge densities. The storm water and drainage. Stormwater management is the effort to reduce rainwater into the streets and other sites in an effort to improve the safety and the improvement of water quality. Moreover, since the site of the dolomitic ground is imperative to adapt, good site drainage plans to reduce the project groundwater are important. A well-planned road layout can assist in the stormwater management. Raised barrier curbs, mountable or semi-mountable curbs along the roadsides are recommended in order to channel the stormwater along the roads. Open lined side drains are also effective in dealing with floods. Regularly spaced inlets and stormwater pipes are recommended to prevent stormwater from overtopping channels and flowing into adjacent properties. Subsoil drains and alongside are engaged. The pounding of stormwater around the exterior of building structures can be avoided by shaping the ground levels around the exterior to create a far away from structures and construction of a 1 meter wide concrete apron with a 10% fall away from houses. The geotechnical risks are as follows. Sorry about that. The problematic soils. The presence of problematic soils will adversely affect the choice of foundation solutions of the in-use development. In South Africa, even the site classification designs in accordance to our science hinge in reliable identification of the soil problems. These are summarized as follows and shall be investigated during the detailed geotechnical phase. The consoluble soils, expansive soils, and dolomitic land. Excavation. The ease of excavation is a very critical financial factor for the development. A number of tests can be carried out to assassinate and excavability of the site, such as DCPs, as mentioned above, and test pit excavations. From the DCP tests, the excavation tempo observed during the field investigation and according to the South African Bureau standardized excavation classification of earthworks and small earthworks. So the following excavations can be classified as follows: soft excavation and hard excavation. Other geotechnical risks can follow groundwater and seismic hazards. Safety. Material investigation for earthworks involved the diggings of test pits for samples, which involved the machines. In other cases, for blasting is involving materials to quarries, core drilling, seismic, or other specialized surveying that may be necessary. All operations that contain elements of danger to the public, to animals, and to people are involved in the investigation site. The responsibility for complying to statutory and common law safety requirements during material investigations lies with consultants. Environmental conditions. The goal of environmental engineering is to ensure that societal development and the use of water, land, and air resources is sustainable. An environmental impact assessment will need to be done by a suitable qualified environmental specialist to assess the environmental impacts that might be caused by the construction activities. The objectives of the environmental impact assessment include improving the environmental design, ensuring that the resources are used properly, and identifying that the appropriate measures to mitigate the potential impacts is proposed. Occupational health considerations. Sampling from test pits and other excavations is very potentially hazardous activity and must only be carried out under great supervision of a very competent person and in strict compliance with the OHS requirements. There's many books that we can consider in that we can use for guidance. And one of them, as mentioned in my report, is the Safety Persons Working in Small Diameter Shafts and Test Pits for Geotechnical Engineering Purposes, and also the Occupational Health and Safety in the Field Test must meet the requirements of the occupational safety measures. Also, an emergency plan must be put into place. So this means that the emergency plan must be drafted and presented to everyone on site. This is done in a form of a toolbox talk to everyone every morning before construction. Smoke and fire condition. Smoking areas should be provided during construction periods, and during construction periods, the areas of chemicals should be separated with tools and dripping plates and under moving machines in case they are leaking. In conclusion, a new industrial In conclusion, desktop information was gathered from various sources to get preliminary site view. So this means that the problems experienced on the Dolomite by South African geotechnical engineers and geologists over the years have led to the development of investigation and the construction techniques which have been used successfully for the founding of a wide variety of domestic and industrial structures. The procedure followed in the Dolomite site can be summarized as follows: access to relative risk occurrence and probable magnitude of the three types of settlement possible on Dolomite. Conduct a geotechnical investigation specifically designed for the site and development in the question. And also you need to reassess the site founding method during the construction. The following methods of investigation are therefore recommended in assessing local geology and obtain design parameters values for foundation and pavements. Field investigations, which include the GPC study, test pits, excavation, laboratory testing, which include the pH and conductivity, the textile strength. Also, that the fact that no testing was done to confirm the type of characteristic of local soils based on weathering and erosion agents, their expected soils might vary from geological deposits and register dolomitic and chat soil. Moreover, expected geotechnical constraints in terms of problematic soil can include the following. Thank you.